Here we're talking about even and odd functions and being able to determine if a function is even or odd. And there's two different possibilities that we might see here is we might see a graph and we have to figure out if it's even or odd by just looking at it, or if we're given an equation to be able to find out if it's even or odd. So the graph is usually pretty easy because if we're looking at a graph, what we're looking for, like for this first one here, is if it's even, it is symmetrical over the y-axis, meaning that if I were to fold, like a piece of paper over this purple line here, it should land on itself, which in this case, it is even because if we were to fold that over, it would land on itself. It is symmetrical over the y-axis. The second one here is talking more about odd functions. Odd functions is a little bit different. It is symmetrical, but what we call it is we call it a rotational symmetry around the origin, meaning like if we were to rotate this 180 degrees, it would land on top of itself. So imagine, right, if we were to take like this piece right here, if we were to rotate that 180 degrees all the way across, well, okay, it would land right here, right? So it's a little bit more difficult to imagine the odd function when we're, rotating it. But really what you should see is should kind of see this pattern here that, if we have, let's say, this was like 1/2, sorry, 0.5 and then 1.5 as the point. Well, for odd functions, basically we're going to take that, we're going to make them both negative. So negative 0.5 and negative 1.5. So if we were to do that, we would then create this point right here. Same with kind of any of these points here, that would just make both of them the opposite sign. And if they land on those points, then we know it's odd. For the equations here, basically there's this idea for even functions that if we were to plug in a negative x value, then we would end up getting our original y value, or the same value that if we plugged in regular x. So basically the way that we would show this is that we would have 5 over 3 minus negative x to the power of 4, and basically try and simplify this, because when we have something that is, actually let me change this parenthesis here, negative x to the power of 4. So when we have this power of 4 here, because it's an even degree, if we had negative x to the power of 4, it would look like this. And then if we multiplied all those things together, well, negative x times negative x is just positive x squared, because a negative times a negative. Same thing with this one here. Negative x times negative x is positive x squared. And then when we multiply these two, we see that the negative really just goes away, because when we raise it to an even power, well, a negative times a negative is positive. So what that means is that this whole thing, when we simplify it, sorry, I ran out of room here, but we get 5 over 3 minus positive x to the power of 4. So what we see here is that when we plug in the negative x value here, we end up getting back to our original function, which is what we call even, right? So if you look in this graph over here in the purple one, really what we're seeing here is that if we plug in, the positive x value of, let's say, 5, we get a positive x value of 5. I don't know if that says 5 or not, but if we plug in negative 5, we go over here, then we also get positive 5, right? So whether we plug in positive x or negative x, we get the same y value. And that's what this equation here that we just did shows. For the last one here, we're going to plug in negative x, and we're going to see if it's even first. So when I plug this in, sorry, I got to change this to g for this one. When I plug in negative x plus the cube root of negative x, a couple of things here. First of all, 1 over negative x is the same as negative 1 over x. And then when we have the cube root of a negative number, remember when we take the square root or an even root of a negative number, we can't do that. That's where we get imaginary numbers. But if we have the cube root, right, like negative 1 times negative 1 times negative 1, like that is possible. We can take the cube root of negative 1. So the negative value really is just going to come out to the outside here. So the cube root of -1 is the same thing as the negative cube root of 1. Same idea goes for this, where we take out the negative, and then it just becomes the cube root of x. And now, the last thing that I'm going to do here is I want to see if it's the same as our original function here where it was plus and positive. So I'm going to try and factor out the greatest common factor of -1. And that gives me back to my original function. Now this is not even though, because I still have this -1 in the front. And that actually tells me that this is going to be an odd function, because we have this rule that if we have a negative x, if we plug that in and we get the negative y value, well then that is an odd function. So in this case here, our second equation is going to be odd. So a couple things about even and odd. First of all, when we're talking about graphs, even are symmetrical around over the y-axis. Odd are rotationally symmetrical, 180 degrees around the origin. For equations, we're going to plug in negative x and we're going to see what we get when we simplify it. If we go back to the original function, we know it's even. If when we simplify it, we get the original function times -1, well, then we know it is odd. If we get neither of those things, well, then it's not even or odd, and that's a possibility as well.